Welcome to Prism Science Academy classes, and we are about to solve. Uh, this is the question paper of year 2024, and this is set 2, subset 1. So for set 2, it's subset 1, and this is for the mathematics standard. We are about to solve the section A. So this section or this question paper has 5 sections A, B, C, and D. In section A, there are 20 MCQs and 90 to 20 are the relation and reason-based questions of 1 mark each. So we are going to solve this section first. That is the section A. And moving on to section A, this is the first question. And it says that the value of k for which the system of equations 3x minus y plus 8 is equal to 0 and 6x minus ky plus 6 is equal to 0 has infinitely many solutions. And we know that for infinitely many solutions, the given set of equations should have their coefficients in the proportion of the variables. For infinitely many solutions, the condition is a1 upon a2 is equal to b1 upon b2 is equal to c1 upon c2. So here a1 is the variable of first equation, variable x of the first equation, which is 3. A2 is the variable coefficient of variable x of the second equation, that is 6. And b1 is the coefficient of variable y of the first equation, which is -1. b2 is minus k. So let's just stick these two to these two only, because this will give us the value of k. So this is 1 by 2, and 1 by 2 is equal to 1 by k. So we cross multiply this, the value of k is 2. So answer for this is B. So B is the correct option for this. Moving on to question number 2. For question number 2, it's given that point P divides the line segment joining the points. So let's say this is the join of these 2 points A and B. So point A is 4 comma minus 5. Let's say these are the coordinates x1 and y1, and point B has the coordinates 1 comma 2. So this is divided by P point in the ratio 5:2. So let this ratio be m1 is to m2. We have to find the coordinates of point P. So we are going to use here the section formula, and section formula says that the coordinates of the point P is given by xy, which is m1 x2 plus m2 x1. This is the x coordinate upon m1 m2, and y coordinate is given by m1 y2 plus m2 y1 upon m1 plus m2. And the easiest way to remember this is 1 with 2, 2 with 1, 1 with 2, and 2 with 1, the variables x and y. So x comma y, that is the variable coordinates of point P. So we have to find the coordinates of the point P. The value of m1 is 5. So I'm going to replace the values. X2 is 1 plus m2 is 2, x1 is 4 divided by m plus 2, which is 5 plus 2. These are the coordinates of x, comma m1 is 5, y2 is 2, plus m2 is 2, and y1 is -5. So upon 5 plus 2 should give us the y coordinate. Okay, if we simplify this, x comma y is equal to 5 plus 8 is 13. So this is 13 comma 7, and this is 10 minus 10 is 0. So this is 0. So 13 comma 13 by 7 0. That is the option C is the correct answer for this. Okay, now let's move on to question number 3. For question number 3, that we have to find the common difference of the AP in which the difference of the 15th and the 11th term. So 15th and the 11th term is 48. And if you use the formula of the nth term, 15th term is a plus 40b. If we use this formula, an is equal to A plus n minus 1 into D. So A15 I can write it as A plus 14D minus A11 is A plus 10D, which is equal to 48. Now A plus 14D minus, if you open up the bracket, which is A minus 10D is equal to 48. A and A gets cancelled. 14D minus 10D is 4D is equal to 48 and D is equal to 12. So common difference is 12. So 12, that is A is the correct option. Now the quadratic equation has dashes, and we know that for question number 4, to find the nature of the roots, we have to calculate D. If it's greater than 0, the roots are real and distinct. And D, if D is equal to 0, the roots are real and equal, and D is the discriminant. And if D is less than 0, roots are not real. Not real. And how do we find D? D is the discriminant. D is equal to B square minus 4AC. And in this equation here, A is the coefficient of x square, which is 1. B is equal to 1. C is equal to 1. Let's replace their values. So this is 1 square minus 4 into 1 into C, which is C is 1. Okay, this is 1 minus 4. 1 minus 4 is equal to minus 3, which is less than 0. Less than 0 means the roots are not real, and the correct option here is D, which is real. Let's move on to the next page. Okay, for next question, it's given there, that is the option number 5th MCQ. The HCF of two numbers is 40, and these are the two numbers 250 and 6600. So these are the two numbers, and HCF of these two numbers is the numbers 2520 and 6600. HCF is 40, and LCM is 2520 into sorry, of 6600. LCM is 252 into K, and we have to find the value of K. So since these are two numbers, so there is a relation between HCF and LCM, and the product of two numbers are the two numbers, that is HCF into LCM is always equal to product of two numbers. That is, this relation is valid for the two numbers, and HCF is 40, LCM is 252 into K. Then the product of two numbers are 2520 into 6600. Okay, we have to find the value of K. So K is equal to 2520 into 6600 divided by 40 into 252. So this is 10, and 4 on the 4, 26, 4 6 are 24, 50. So value of K is 1250. And 1250 means our option is, sorry, this is 1650. So 1650, that means our correct option is option A. And moving on to the sixth question. For sixth question, it's given in a triangle. This is question number 6. This is the triangle ABC in which DE is parallel to BC. So DE is parallel to BC means these two triangles, the upper one ADF and BC, these are similar because DF is parallel to BC. So this angle, that is 1 and 2, are equal because these are the corresponding angles. So angle 1 is equal to angle 2, and similarly angle 3 is equal to angle 4. DF is parallel to BC. So 3 is equal to angle 4, and this is because these angles are corresponding angles, and if these are equal, that means triangle ADF is similar to triangle ABCD. BC by AA rule, by AA similarity rule. So if these triangles are similar, so that means the sides are in proportion, that is AD upon AB should be equal to DF by BC. Now AD is 5, so this is 5 centimeter, and DB is 2.5 centimeter, so this is 5 by 2.5, and DF. So, okay, sorry, this is triangle ADE. So this is DE. So DE and AB. The value of AB, this is AB, which is 5 plus 2.5 is 7.5. So this is 7.5 D upon BC, which is 12. And if we cross multiply this, that is equal to D is equal to 5 into 12 by 7.5. And if we take off this decimal, so this 5 into 12 into 12 by 75, 5 twos are 10, 5 ones are 5, 5 fives are 25, 3, 4, and DE is equal to 8 centimeter. So DE is equal to 8 centimeter is the correct option for question number 6. For question number 7, it's given that sine theta is equal to cos theta. And we know that the angle for which the value of sine and cos is equal is 45 degrees. So cos theta, so that means theta is equal to 45 degrees, because for 45 degree, sine and cos are equal. Or rather, we can also evaluate it this way. Let's divide sine. If these are equal, then that means sine theta by cos theta should be equal to 1. And sine theta by cos theta is tan theta. And we know that the tan for which the angle for which the value of tan is 1 is 45. So that means theta is 45 degree. Now, if the theta is 45 degree, we have to calculate secant theta. So secant theta into sine theta. And theta is 45 degrees, so secant 45 degree into sine 45 degree. Now secant 45 is the reciprocal of cos 45, which is root 2. Sine 45 is 1 by root 2. And answer for this is 1, which is option C. For question number 8, two dice are rolled together. The probability of getting the sum of two numbers to be more than 10. Okay, for question number 8, for dice when rolled together, total outcomes for single die it's 6, and because there are two dice, so put it in power, and the total outcomes are 36, and sum of the two numbers on two dice more than 10. So 10 comes when either it's 4 on the first die and 6 on the second, or 6 on the first and 4 on the second. So this gives us 4 plus 6, 10, and 10, but it should be more than 10. And so that means either it's 5 plus 6 or 6 plus 5 on the other die. So these are the two outcomes in which the sum is greater than 10. And the next outcome on which the sum is greater than is 6 and 6 is this is also greater than 10. So we have total of three outcomes. So probability of getting sum greater than 10, the total events we have is 3. So probability of getting sum on two dice greater than 10 is equal to, this is 10, is equal to 3 by 36, which is equal to 1 by 12. So 1 by 12 is the correct option. Okay, for question number 9, it's given that alpha and beta are the zeros of the polynomial. This is question number 10. Okay, for question number, sorry, 9. The alpha and beta are the zeros of the polynomial. Given zeros are 5x squared plus 3x minus 7, where a is the coefficient of x squared, which is 5, b is the coefficient of x, 3, and c is negative 7. Now alpha and the beta are the zeros, and we know that sum of the zeros is given by minus b by a. So alpha plus beta is equal to minus b is 3 by A is 5, and product of the zeros is given by C by A, and alpha beta, this becomes equal to minus 7 by 5. So we have alpha plus beta is equal to minus 3 by 5, alpha beta is equal to minus 7 by 5, and we have to find the value of 1 by alpha plus 1 by beta. So alpha beta gives us, if we take the LCM, it is beta plus alpha, so beta plus alpha is minus b by a, and we will put its value, and alpha by beta is c by a. So let's replace the values. Minus 3 by 5 and minus 7 by 5 should give us 3 by 7. So 3 by 7 means C is the correct option. Let's move on to question number 10. For question number 10, it's given that the perimeters of two similar triangles ABC and PQ are 56 and 48 centimeter respectively. And it's given that triangle ABC is similar to triangle PQR. Now, we know that when the two triangles are similar, then their perimeter, that is perimeter of these two triangles, their ratio, perimeter of triangle ABC and perimeter of triangle PQR is equal to, that is the ratio of the two similar triangles is equal to the ratio of the either of the pair of the corresponding sides. That is, I can take AB by PQ. I can write it as AB by PQ. Now the perimeter of triangle ABC is 56, perimeter of triangle PQR is 48, and we have to find PQ by AB. So let's find AB by PQ. So 8 7, that is 56, 8 6 are 48. This is 7 by 6. So PQ by AB is equal to 6 by 7. Let's reciprocal this. So 6 by 7, that is B is the correct option for this question, which is 6 by 7. Okay, moving on to the next question. Let's move on to the next question, that is question number 11. For question number 11, it's given that these are AB and CD are two chords of a circle intersecting at P. We have to choose the correct statement. So in this case, these two triangles, now angle A is equal to angle C because these are the angles on the same segment. So angle A is equal to angle C. These are the angles on the same segment DB. And we know that angles on the same segment are equal. So angles on same segment are equal. And also angle P is equal to angle P. Angle P is equal to angle P. These are the vertically opposite angles. So that means by AA similarity rule, this triangle, because the first triangle is on all these options is mentioned ADP. So I will write the symbolic form as ADP is similar to triangle. Now, angle A was equal to C. So corresponding to A, I will write C, and P was equal to P, and the left is CBP. So triangle ABP similar to triangle CBP by A similarity rule. And for this, the correct option is D. Moving on to the next one, that is question number 12. It's given that if each value of the observation in a data is increased by 2, then median of the new data is also increased by 2. Because the observation is increased by 2, so that means there is a value increase of 2 in each value, and if there is increase of value increase of 2 in each value, then that means that the value is increased equally for all the values, and then if it's increased by 2, so that means the median is also increased by 2. For question number 13, a box contains cards number 6 to 55, so total cards from 50 to 65 are 50. So total cards are 50. Now a card is drawn at random. What is the probability that card drawn has a number which is perfect square? So between 6 to 55, perfect square starts from 3 square 9, 4 square 16, 5 square 25, 6 square 36, and 7 square 49, and 8 square 64, which is greater than 55. So we have a total count of 5 perfect squares between 6 to 55, and probability of getting a perfect square. So probability of getting a perfect square is 5 by total cards 50, which is equal to 1 by 10. And 1 by 10 means C is the correct option. Let's move on to next question, that is question number 14. Okay, for question number 14, it's given that tangents PA and PB to the circle centered at O from point P are perpendicular to each other. So this angle is 90 degree. If PA is 5 centimeter, then the length of AB, we have to calculate the length of AB. So AP is equal to PB. PB is also 5 centimeter, and in this question, that is question number 15, AP is equal to PB is equal to 5 centimeter. Reason being, length of tangents drawn from an external point to tangents drawn from external point to a circle are equal. Okay, now in triangle APB, which is a right angle triangle, because angle P is 90 degrees, so I can write in right angle triangle APB. I can use the Pythagoras theorem and the side opposite to 90 degree. AB is the hypotenuse, so AB square is equal to AB square plus EB square, and both being 5 centimeter, it's 5 square plus 5 square. 25 plus 5 is 50. AB square, and AB square is, I can write it as 5 into 5 into 2, which gives us 5 root 2 centimeter. So 5 root 2 centimeter means option B is the correct option here. Okay, moving on to question number 15. It's given that XOYZ is a rectangle with vertices on the Cartesian plane, in the Cartesian plane. So let's say this is our Cartesian plane with the X and Y axis. Okay, these are the axis, coordinate axis with Y and X vertical axis. Now XOYZ is a rectangle with vertices X minus 3 comma 0. So let's say this is minus 1, minus 2, and a minus 3. So this vertex minus 3 comma 0, this is minus 3 comma 0, and this is X. And O is at origin, this is O, and Y is 0 comma 4. So this is 1, 2, 3, and 4. So this is 0 comma 4, which is Y. So X, O, Y, and Z. Okay, so this is minus 3 comma 0, 0 comma 0, 0 comma 4 is X, O, Y, and Z is X, Y. We have to find the length of the diagonal and each of the diagonals, and we note that the diagonals in the rectangle are equal, so we can find either one of them. So this is the diagonal, and this distance is, this is 0 comma 4, so this distance is 4 units, and this distance is 3 units. This being a right angle triangle, this is the hypotenuse, so hypotenuse is the square of the sum of the sides. So 3 square plus 4 square, 9 plus 16 is 25. So this is root, and root of 25 is 5. So 5 units is the correct option. And moving on to question number 16. Which term of the AP is the 16th term? So given AP is minus 29, minus 26, minus 23, 61. And we have to find which term is 61. So A here is minus 29 and D is minus 26 minus or minus 29. Minus 26 plus 29 is equal to 3. Okay, so D is 3 and let nth term be 16. So nth term is equal to 16 and nth term is A plus n minus 1 into D is 16. A is minus 29 and minus 1. D is 3 and n minus 1 into 3 is now equal to 16 plus 29, which is equal to 45. And if you strike off with 3, this is 15. So n is equal to 16, means it's the 16th term. Okay, for question number 17. In question number 17, in the given figure, AT is tangent to a circle centered at O. If angle CAT is equal to 40 degree, then angle CBA is equal to. Okay, this is the angle in a semicircle. So this angle is 90 degree because angle BCA is equal to 90 degree because angle in a semicircle is right angle. So this is the angle in a semicircle is a right angle 90 degree. Now OA is perpendicular to AT, reason being radius is perpendicular to tangent at the point of contact. So that means, let's say this be angle 1 and this be angle 2. So if OA is perpendicular to AT, so that means angle OAT is 90 degrees. So angle OAT is 90 degree and angle OAT it is the sum of angle 2 plus angle CAT, which is 40 degrees. So this is angle 2 becomes 90 minus 40 is equal to 50. So this angle, one angle is 90 degree, this is 90 degree, and this is 50 degree. And if you use the angle sum property in this triangle, which gives us 90 plus 50 is 140 minus 180 minus 140 is 40. So this angle is 140 if we use the angle sum property, which is 180 minus 50 plus 90. So 180 minus 40 is 40 degree. So 40 degree is the option D. Okay, for question number 18, after examination, the teacher wants to know the marks obtained by maximum number of students in a class. So maximum number of students in a class, they have obtained what marks? That means the maximum frequency. And we know that uh, an observation with the maximum frequency is called mode. So correct option for this is mode. Moving on to question number 19 and 20. For next question, that is question number 19. These are the reasoning based for question number 19 and 20. And question number 19 says that sine A is equal to 1 by 3, where A is the angle between 0 and 90 degree. So this is question number 19, and it says that if sine A is equal to 1 by 3, when sine A is 1 by 3, the value of cos A is 2 root 2 by 3. So let's try to find out using the identity. We know that sine square A plus cos square A for every angle A is 1, and we have to calculate cos. So cos A is equal to under root cos A is equal to under root of 1 minus sine square A, and sine square A is 1 by 3 the whole square, which is 1 minus 1 by 9, which is under root 9 minus 1 is 8 by 9. So this is 2 root 2 by 3. This is the value of cos A, which is correct. And we have calculated this using the identity sine square theta plus cos square theta is equal to 1 for every angle theta. So that means this is true, and this is also the correct reason for this. So that means both assertion A and reason are true, and reason R is the correct explanation of assertion A. So our option is A for this, for question number 19. Okay, moving on to question number 20. It gives that two cubes, each of edge length 10 centimeter, are joined end to end. So these are two cubes. They are joined end to end. This is 10 centimeter. This is 10 centimeter. This is 10 centimeter. This is 10 centimeter. Okay, and this is the resulting cuboid. So this resulting cuboid has length of this resulting cuboid is 10 plus 10 is 20, breadth remains 10 centimeter, and height is 10 centimeter. Now the total surface area of the newly formed cuboid is 1200. So let's calculate the total surface area. So total surface area is 2 into LB plus BH plus LH. Let's put in the values. Length is 20, breadth is 10, breadth is 10, height is 10, length is 20, height is 10. So this is equal to 220 into 10 is 200, 100 plus 200. So this is 500. 200 plus 200 is 400, 500, and 500 into 2 is 1000. So 1000 centimeters square is the total surface area of the newly formed cuboid. So that means assertion is wrong, and area of each surface of a cube of side 10 is 100 centimeters square is also wrong, because the area of the cube is given by 6 into side square, which is 6 into 100, that is should be equal to 600 centimeters square. So both assertion A is, so this is length is 20, breadth is 10. LB plus PH 10 into 10, length is 20 into 10, 200, 100, 200. 200 plus 200 is 400, plus 100 is 500, into 2 is 10,000. Okay, for this question, for question number 20, assertion A is not true. Assertion A is not true, and area of each surface. Okay, sorry. So this, so assertion is not true because the total surface area of the resulting cuboid is 1000 centimeters square. Now area of each surface of cube. So each surface of the cube is a square, and area of the square is 10 into 10, that is equal to 100 centimeters square. So assertion is not true, and but reason R is true. So we can, from this option, assertion is not true, but reason R is true. So this is false and this is true, which makes us to choose the option D. So option D is the correct answer for question number 20. Okay, now the section B. In section B, this section consists of 5 questions of 2 marks each. And the first question is, can the number 15 raised power n being a natural number, n in digits 0 or not? So let's try to understand this question. N is a natural number, and natural number starts from 1, 2, 3, 4, and goes on like this. 1 being the smallest. And if n is equal to 1, which gives us 15 raised power n, that is 15 raised power 1 is equal to 15. And if n is equal to 2, which gives us 15 square is equal to 2 to 5. Similarly, if n is equal to 3, we can calculate the value of 15 cubed. Now we have to check if this is ever going to end with the digit 0 or not. So to end with digit 0, suppose let's say there is a number that ends with digit 0. Now if this number ends with digit 0, so that means it is for sure it should have prime multiples 2 and 5. So that means it's always divisible by 5. And here, or it's always, now the prime factorization of 15 raised power n is 3 into 5 raised power n. So can the number being a natural number end with the digit 0? And to end with digit 0, it should have both these prime numbers 2 and 5, but there is only 5. So that means this, because the prime factor 2 for a number to end with digit 0, because if there is 10, then it has prime factors 2 and 5. So for a number to end with digit 0, if it's 100, if it's 100, if it's always 25, 5 into 5 into 5 into 5 into 2 into 2. So that means both the prime factors 2 and 5 are must for a number to end with digit 0. And if it's 50, it has 2 and 5, but 15 has the prime factors as 3 and 5 where there is no 2. So that means for a number to end with digit 0, it has two prime factors 2 and 5 both. For a number to end with digit 0, it should have both 2 and 5 as its prime factors. But in this case, 15 does not have 2 as a prime factor. So 15 raised power n, which is equal to 3 into 5 raised power n, has does not have 2 as a prime factor. So I can write that it does not have 2 as a prime factor. So this, so it cannot end with 0. So I can write that it means 15 raised power n cannot end with digit 0. Okay, so this solves our question number 21 of section B. Let's move on to question number 22. Okay, for question number 22, we have to find the type of triangle ABC formed whose vertices are A, B, and C given. So let's say this is a triangle ABC, and we have to find the type of the triangle. So this is A vertex, its coordinates are 1, comma 0. This is vertex B, its coordinates are minus 5, comma 0. And this is C vertex, its coordinates are minus 2, comma 5. Okay, we have to find the type of the triangle. So let's find out the length of the sides using distance formula. So AB is 1 minus of minus 5 the whole square plus 0 square, and so this is 1 minus of minus 5 is 6, 6 square is 36, so root of 36 is 6. So we have got AB using the distance formula, which is 6 Let's try to find out other sides BC. So here BC is equal to minus 2 minus of minus 5 the whole square plus 5 minus 0 the whole square, and it's all in the root. So minus 2 minus of minus 5 is minus 2 plus 5 is 3 square is 9 plus 5 square is 25. So this is root 34. Let's find out the third side, and the third side is CA. So CA is equal to minus 2 minus 1 the whole square plus 5 minus 0, that is 5 square, and it is once again 9 plus 25, which is equal to root 34. Okay, in this case, these two sides BA is equal to CA is equal to root 34. So that means triangle ABC is an isosceles triangle. Okay, so and moving on to next question, which is question number 23, we have to evaluate the values for the trigonometric angles, the trigonometric ratios of certain angles. And it's question number 23, part 3. And it's given that 2 sine squared 30. So it's 2 sine square 30 degree into secant 60 plus tan square 60. We have to evaluate this. Now let's put in the value of sine 30. Sine 30 is half, so this is half square into secant 60. Cos 60 is half, so secant 60 is 2. Tan 60 is root 3, so it's square. So this is now 4 into 1 by 4. Root 3 square is 3. So this is equal to 1 plus 3 is equal to 4. And let's try to solve the second one, that is the part B as well, where it's given 2 sine of A plus B is equal to root 3, which gives us sine of A plus B is equal to root 3 by 2. Now, we know that for sine 60, the value of sine 60 is root 3 by 2. So instead of this, I can write sine 60, which gives me A plus B is equal to 60 degree, like this equation 1. And further is given that cos of A minus B is equal to 1. So cos of A minus B is equal to 1, and we know that the angle for which the value of cos is 1 is 0. So instead of 1, I can write cos 0, which gives me A minus B is equal to 0 degree. So we have these two equations, and I'm going to solve these two equations. So A minus B is equal to 0. This is second equation. If I add these two equations, it gives us 2A is equal to 16, which gives me A is equal to 30 degree. And from this equation, 30 minus B is equal to 0, which gives me minus B is equal to minus 30. So B is also equal to 30 degrees. So in this case, the angles A and B both are equal to 30 degrees. Okay, let's move on to next question, that is question number 24. Before that, I'm going to raise all these. Okay, for question number 24. In the given figure, AB and CD are tangents to a circle centered at O. So we have to show that is BAC is equal to angle DCA. Okay, for this, let's join this OA to OC. And so this is question number 24. So in this case, OA is equal to OC. The reason being, these are the radii of same circle. And we know that if two sides are equal, then angles opposite to two sides are equal. That means angle OAC is equal to angle OCA. And the reason here is these are the angles opposite to equal sides. And we know that the angles opposite to equal sides are equal. Okay, now OA is perpendicular to tangent AB and OC is perpendicular to tangent CD. And for these two, the reason is the radius is perpendicular to tangent at point of contact. So this was our, let's say, first equation. So if OA is perpendicular to AB, so that means angle OAB is equal to 90 degree and angle OCD is also 90 degrees. So that means angle OAB is equal to angle OCD. And this means second reason is each is 90 degree. So we are going to add 1 and 2. So if I'm going to add 1 and 2, that means LHS to LHS. So this gives me angle OAC plus angle OAB is equal to angle OCA plus angle OCD. Now angle OAC plus angle OAB. OAC plus angle OAB gives me angle BAC. So this gives me the angle BAC and OCA plus OCD. If I add OCA and OCD, this gives me angle AC. So angle AC. This is what we were asked to prove in this question. So we have justified this. Okay, moving on to the next question, that is question number 25. For question number 25, we have to find the ratio in which the line segment joining the points. So this is question number 25th, part A. We have to find the ratio in which the line segment joining the points 3 comma minus 5 and 1 comma minus 1 comma 6 is divided by the line y is equal to 6. So let this be a line that joins the 2 points, and let these points be A, 3 minus 5, and this be B, minus 1 comma 6. And let B be the point, P be the point that divides this line in the ratio k is to 1. And this P, it passes through, or let me just say that there is a line y is equal to x. So this is the line, and this line equation, this line's equation is y is equal to x, and it intersects this line at point P. So P divides this line in the ratio k is to 1, and using the section formula, we can find out the coordinates of, so coordinates of P are, and we know the section formula is m1 x2 plus m2 x1 upon m1 plus m2, and this is m1 y2 plus m2 y1 upon m1 plus m2. And we know that this is m1, this is m2, this is x1 y1, and this is x2 y2. If we replace their values, m1 is k into x2 is minus 1, m2 is 1, x1 is 3 upon k plus 1 column. This is m1, m1 is k, y2 is 6, m2 is 1, and y1, y2 is 6 and y1 is negative 5 upon k plus 1. Okay, so this is equal to minus k plus 3 upon k plus 1. This is 6k minus 5 upon k plus 1. These are the coordinates of. Now this p coordinate, it lies on y is equal to x. So these are the coordinates of p, and these points, that is the x comma y, lies on the line y is equal to x. So that means I can replace these values in this equation. So since, or I can say that since p lies on y is equal to x. So let's replace the value. So this is, so that means that this point is going to satisfy this equation. So I'm going to put y. This is y and this is x. So k plus 1 is equal to x is minus k plus 3 upon k plus 1. And this gives me 6k plus k is equal to 3 plus 5. So 7k is equal to 8 and k is equal to 8 by 7. So the required ratio is 8 is to 7. So 8 is to 7 is the required ratio for question number 25, first part. Moving on to part B of the same question. It's given that A, B, and C are the vertices of a triangle ABC. We have to find the length of the median B. Now, median, we know that median is a line segment that is drawn from the vertex of a triangle to the midpoint of the opposite side. And we have to find its length. So this is question number part B of question number 25. So B, and let's say this is our triangle ABC. This is the median BE. Okay, so this is the triangle ABC with given coordinates. A is 3 comma 0, B is 6 comma 4, and C is minus 1 comma 3. And this is the median BE. That means E is the midpoint. So coordinates of E, we can find the coordinates of E using the midpoint formula. And the midpoint formula says that the coordinates of E are x1 plus x2 by 2, y1 plus y2 by 2. And for E, these are our x1, y1, and x2, y2, which gives us the coordinates of ES. This is 3 plus of minus 1 is 2 by 2, comma y1 plus y2 is 0 plus 3 is 3 by 2, which gives us the coordinates is 1 comma 3 by 2. Now we have to find the length of median BE, which we will find out using the distance formula. So E has the coordinates 1 comma 3 by 2. So this is x1 minus x2 the whole square, which gives me 6 minus 1 the whole square, plus 4 minus 3 by 2 the whole square. So 6 minus 1 is 5, 5 square is 25, and this is 8 minus 3 is 5 by 2 square. This is under root. So 25 plus 25 by 4 under root, which gives us 125 by 4 under root, and 125 can be written as 5 into 5 into 5. So root and root of 4 is 2, so which gives us 5 under root 5, 2 units is the length of the median B. All right, moving on to section C, which says that it consists of 6 questions of 3 marks each. So we are going to solve this one. That is question number 26 for parts A and B. So for question number 26, part A and B, the first question is that if sum of the first m terms of an AP is same as sum of its first n terms, so that means it's question number 26, part A. It's given that sum of n terms is equal to sum of n terms. It's given, and we have to show that sum of m plus n terms is equal to 0. That is, we have to show that 2a, that is sum of m plus n terms. Using the sum of n terms formula, it is m plus n by 2 into 2a plus m plus n minus 1 into d is equal to 0. That's what we have to show. So let's consider this. Now sum of m terms is m by 2 into 2a plus m minus 1 into d, and sum of n terms is n by 2 into 2a plus n minus 1 into d. Okay, so we can cancel out 2, and let's open up the brackets 2am plus m minus 1 into dm is equal to 2an plus, let's multiply this n minus 1 into dn. So I have multiplied m with both the terms, and let's shift 2an to the left hand side. So 2am minus 2an is equal to n minus 1 into dn minus m minus 1 into dm. So 2a is common and it's m minus n. And common here is d. So this is m minus n into n. This is d. Minus m minus 1 into m. I'm going to open up this bracket. So this is 2a into m minus n is equal to d. Or let's open this. This is n square minus n. And this would be minus m square plus f after opening up the bracket. So for n square, let me take out negative out. So this is negative d. And if we take negative out, this is going to change, alter the sign for all these. M square minus m, and this is 2a m minus n. Okay, so 2a into m minus n is equal to negative d. And this is, let's regroup this, m square minus n square, and for these two terms I'm going to take negative out, so which gives me m minus n. And this is a square minus b square, so this is negative d. A square minus b square is a plus b into a minus b minus m minus n. And this is 2a into m minus n. Alright, so 2a into m minus n is equal to, this is d m minus n, and this is m plus n minus 1. So this gets cancelled. And finally, we have 2a plus b into m plus n minus 1 is equal to 0. Now, if we substitute this value in the sum of m plus n terms, so this was the value of sum of m plus n terms. So sum of, we have to find out, show that the sum of n plus n terms is 0. So sum of n plus n terms is given by m plus n by 2 into 2a plus m plus n minus 1 into d. Now this value is 0. So which gives me m plus n into 2 into 0, and anything multiplied by 0 is 0. So sum of m plus n terms is 0. Okay, moving on to the next question where we have to find the numbers for an AP, and it's given that okay, in an AP the sum of three consecutive terms is 24, and we are going to use a concept here that whenever in an AP the sum of three consecutive terms sum is given, we are going to consider the terms, three consecutive terms of an AP as a minus d, a and a plus d. So let three consecutive terms of an AP be a minus d, so whenever in an AP the sum of three consecutive terms is given, we are going to consider the three consecutive terms as a minus d, a and a plus d. So the first information is that a minus d plus sum of these three terms is 24. So d and d gets cancelled, which gives us 3a is equal to 24, and the value of a is 8. Now the further is given the sum of their squares. So sum of the squares of these terms. First term is a minus d the whole square. Second term is a square, and the third term is a plus d the whole square. So sum of their squares is equal to 194. Let's replace the value of a. So this is 8 minus d the whole square plus 8 square plus 8 plus d the whole square is equal to 194. So 8 minus d the whole square is 64. A square plus b square minus 2ab plus 64. So 8 square is 64. A square plus b square plus 2ab is 16d is equal to 194. So this gets cancelled, and 64 plus 64 plus 64 three times is 3 4 plus 12. It's either 18 plus d square is equal to 194. 3 4s are 12, 92. So this is 194, which gives me d square is equal to 194 minus 192. Okay. And this is actually 2d square. So this is 2d square. So 2d square is equal to 2, which gives me d square is equal to 1. And now d is, so the value of d is plus or minus 1. So when d is equal to 1 and when d is equal to minus 1, let's get the value of a. So there are two values of d, plus and minus 1, but the value of a is 8. So we have to find the three terms, and let's get these two scenarios. So when a is equal to 8 and d is equal to 1, three terms are 8. Sorry, the first term was a minus d. So a minus d, a and a plus d. So a minus d means 8 minus 1 is 7. 8 plus d is 9. These are the three terms. And when a is equal to 8 and d is equal to minus 1, the three terms a minus d, a and a plus d. So 8 minus of minus 1 is 9. This is 8, and 8 minus 1 is 7. So when a is equal to 8 and d is equal to minus 1, these are the three consecutive terms. And when a is equal to 8 and d is equal to 1, these are the three consecutive terms. That is 7, 8, 9, or 9, 8, 7 are the numbers of the AP. Let's move on to question number 27. For next question, we have to prove that root 5 is irrational, and this is question number 27. And for this, we are going to assume that root 5 is a rational number. So let's say let root 5 be a rational number. Now, root 5 is equal to p by q. If it's a rational number where q is not equal to 0, and p and q are co-primes. Now, if let's cross multiply this, root 5 is equal to pq, which gives us root 5 into q is equal to p. And if we square on both sides, square on both sides will give us root 5 q the whole square is equal to p square, which gives us 5q square is equal to p square. So 5q square is equal to p square, where q and p are co-primes, which means, that p square, so this means that p square is divisible by 5. And if p square is divisible by 5, square of a prime number is divisible by 5, then that prime number is also divisible by 5 according to the theorem. So let's say this is our first result. Now, if p is divisible by 5, let's say if p is divisible by 5 and we get this quotient a with remainder 0, and using the division algorithm we will get that p is equal to 5 into a, where a is some integer. Okay, let's replace this value of p is equal to 5a in 5q square is equal to p square. So this implies p is equal to 5a. Let's replace this value here. So which gives me 5q square is equal to value of p is 5a. So this is 5a the whole square. And which gives me 5q square is equal to 45a square. This is 5, and finally its q square is equal to 5a square. Now q square is equal to 5a square implies that q square is divisible by 5. So q square is divisible by 5. If q square is divisible by 5, that means q is divisible by 5. This is our result. So from 1 and 2, we have got that p and q are divisible by 5. So P and Q are divisible by 5, but P and Q were co-primes. So which leads to, so 1 and 2 leads to contradiction. So this leads to contradiction that P and Q are co-primes. Co-primes. So that means our assumption was wrong, and hence we can say that hence root 5 is irrational. So that is how we prove that root 5 is an irrational number. Okay, moving on to question number 28, part A. Okay, for question number 28, part A, in the given figure, it's given that PQ is a tangent to a circle centered at O, and angle BAQ is 30 degree, and we have to show that BP is equal to BQ. And for this, I'm going to join OQ, and now this angle OAQ. So this is question number 28, part A. We have to show that BP is equal to BQ. Okay. Now this angle with OA is equal to OQ, and this is because these are the radii of same circle. So if OA is equal to OQ, so that means angles opposite to them are equal. So that means angle OAQ is equal to angle OQA. They both are equal, and it's given that OAQ is 30 degrees. So this means angle OQ is 30 degrees. So this angle is 30 degrees. So this angle is 30 degrees. Reason being angles opposite to equal sides are equal. So if this angle is 30 degree now, OQ is radius, so OQ is perpendicular to tangent PQ, because we know that radius is perpendicular to tangent at the point of contact, so that means angle OQP is equal to 90 degree. Before that, let's consider this angle AQB. So angle AQB is 90 degree because this is the angle in a semicircle. And we know that angle in a semicircle is a right angle. So this angle AQB is 90 degree, and AQB, this angle AQB is the combination of angle OQA plus angle OQB. And we know the value of OQA, so OQ is 30 degree. So this is 30 plus angle OQB is equal to 90, which gives us angle OQB is equal to 90 minus 30 is 60 degree. So angle OQB, this angle is 60 degree. So far what we have got that this angle is 30 degree. So this is 30. And because this was 90, so this angle is 60 degree. Now, this angle is the exterior angle for the triangle AOQ. So for triangle AOQ, now angle BOQ is equal to angle OAQ plus angle OQA. The reason being, this is the exterior angle is equal to the sum of interior opposite angles. Okay, now, so this gives me the angle OAQ is equal to 30. This is 30, which gives me 60 degrees. So angle BOQ. So angle BOQ is 60. This angle is 60 degree. Now, if we use the angle sum property in angle O in triangle OQP, that should give me the value of angle OPQ. Okay, now I can use the angle sum property. So this is 60 and this is also 60. So this is 60. These both angles are 60 degree each. This is 60 and this is also 60 so far we have got. Now this OQ is perpendicular to PQ because we know that radius is perpendicular to tangent at point of contact. So that means angle OQP is equal to 90 degree and OQP is a combination of angle OQB plus angle PQB is equal to 90 and we know the value of OQB which is 60. So 60 plus angle PQB is equal to 90 which gives me angle PQB is equal to 90 minus 60 is equal to 30. So this angle is 30 degree. Now we can use the angle sum property in triangle. This is the bigger triangle OQP. Now angle O plus angle Q plus angle P is equal to 180 degree and O is 60, angle Q is 90, angle P. So 60 plus 90 is 150. That gives me angle P is equal to 150 minus 180 minus 150, which is equal to 30, and angle P is this one. So this is also 30 degree. Now, because these two angles are equal, so that means uh, finally what we have got that angle PQB is equal to angle VPQ. So these two angles are equal, both being 30 degree. So that means sides opposite to them BQ is the side opposite to P, and so this means BP is equal to BQ. And the reason here is these are the sides opposite to equal angles are equal. Okay. So we are done with part A and moving on to part B, where we have to show that angle AOB plus angle COD is 180 degree. Okay, for question part B, it's given that AB, BC, CD, and D are tangents to a circle forming quadrilateral ABCD that circumscribes this circle. We have to show that angle AOB plus angle COD is 180 degree. So we have to show that this plus this is 180 degree, and for this what we are going to do, we are going to join these, making these a radius. So let this, okay, let the point of contact of the tangents, let me name it as P, Q, R, and S. And I'm going to join this. This is OP, this is OQ, this is OR, and this is OS. Now these are, so what I have done here is I have joined, this is part B, This is part B. So I have join O to B, O to Q, O to R, and O to S. And let these be the angles, angle 1, 2, 3, 4, 5, 6, 7, and 8. Now, for triangle or in triangle POC and triangle COQ. OP is equal to OQ. These are the radii of same circle, and OC is equal to OC, that is common. Also, PC is equal to CQ. These are the tangents drawn from an external point to the circle are equal. Okay, so that means that these two triangles, they are congruent by SSS2. So triangle POC is congruent to triangle COQ by SSSB. So if they are congruent, that means angle 1 is equal to angle 2 because these are the corresponding parts of the congruent triangles. Similarly, we can prove that angle 3 is equal to angle 4, angle 5 is equal to angle 6, and angle 7 is equal to angle 8. Let this be our first result. Now, if we add all these angles, that is angle 1 plus angle 2 plus angle 3 plus angle 4 plus angle 5, 6, 7, and 8, and this all these makes a complete angle 360-degree. So 1, 2, 3, 4, 5, 6, and 8. Now we have to show angle AOB. Now angle AOB is the combination of 4 and 5. So we are going to keep 4 and 5. And angle COD is a combination of 1 and 8. And we are going to keep 1 and 8. And we are going to replace all other values. So angle 1, I'm going to keep angle 2 is equal to angle 1. So instead of angle 2, I'm going to put angle 1. Angle 3 has to be replaced with angle 4, and angle 5, I'm going to keep this. Angle 6 has to be replaced with angle 5, and angle 7 has to be replaced with angle 8 plus angle 8 is equal to 360-degree, and all this is because of the results in 1. So this is 2 times angle 1, 2 times angle 4, 2 times angle 5 plus 2 times angle 8 is equal to 360 degree. Let's take 2 common. So angle 1 plus angle 4 plus angle 5 plus angle 8 is equal to 360, which is now 180. Now 4 and 5 4 and 5 gives us angle AOB. So instead of 4 and 5, I can write angle AOB, and 1 and 8 will give me angle COD. So this is equal to 180-degree, and hence we have proved that angle AOB plus angle COD is equal to 180 degrees. Let's move on to question number 29. Okay, for question number 29, we have to prove that LHS of the identity is equal to RHS. So I'm going to write down LHS, which is 1 plus secant theta minus tan theta upon 1 plus secant theta plus tan theta. Okay, and between secant and tan, there is an identity which says that 1 plus tan square theta is equal to secant square theta, which gives us 1 is equal to secant square theta minus tan square theta. So I'm going to replace 1 with this value secant square theta minus tan theta. So our LHS becomes, this is secant square theta minus tan square theta plus this is secant theta minus tan theta upon 1 plus secant theta plus tan theta. Now this is a square minus b square, so we know that a square minus b square is a plus b into a minus b, and after that it's plus 1 and secant theta minus tan theta. So this is our numerator, and denominator is 1 plus secant theta plus tan theta. Okay, for the numerator, we have this term. This is the first term, and this is the second term. And in these two terms, common is secant theta minus tan theta. So this is secant theta minus tan theta. So secant theta minus tan theta is common, which gives us secant theta plus tan theta here, and here it's 1. And now we see that this term is the same as the denominator, so we can strike this off. And finally, we are left with secant theta. So secant theta is 1 by cos, and tan is sine by cos. So taking LCM will give us the RHS of the identity. So this is 1 minus sine theta by cos theta. Moving on to next question, where we have to find the mean marks of the students. Okay, for question number 30, we have to find the mean marks of 100 students out of 50. So marks obtained are in the class intervals. These are the class intervals 0 to 10, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. These are the class intervals, and number of students, that is the frequency, is 12, 23, 34, 25, and 6. And I'm going to find out the class marks, which is upper plus lower divided by upper limit plus lower limit divided by 2. So 0 plus 10 is 10, divided by 2 is 5, 10 plus 20 is 30, divided by 2 is 15, and after that it's 25 and 35, and last one is 45. I'm going to use the direct method. So let's find the product of the frequency and the class mass. 12 into 5 is 60. 23 into 15 should be 345. 34 and 25 is 850. So you can use any of the method here because it's not mentioned in the question that you have to use a particular method. So I'm going with the first one. 25 into 35 is 875. 6 into 45 is 270. So fi into xi, if I multiply this, this is 10, 6 plus 4, 10, 11, 5, 16, 7, 23, and 7 is 30, and 3, 3, 6, 8, 14, 8, 22, and 2 is 24. And here, the total number of students are 100, so sigma fi is 100. And now we have to find the mean, which by the direct method should be the summation of the product of frequency and class marks divided by the summation of frequency. So that is 2400 divided by 100, which gives me the value as 24 as the mean marks of the students. Okay, moving on to question number 31. For question number 31, it's given that in a two-digit number. So this is question number 31, and we know that a two-digit number is given by as this is a two-digit number where this is units place, and this digit is at tens place. So it's given that the date at units place is less than the date at tens place by 5. So let's assume that the digit in tens place be x. Okay, and now digit at units place is 5 less than the digit at tens place. So this is x minus 5. Now, according to question, it's given that the product of the digits, that is x into x minus 5 is the product, and this is equal to 36. So if you multiply this, this is x squared minus 5x minus 36 is equal to 0, which is a quadratic equation. And we are going to solve this using the factorization method. A is 1, B is minus 5, C is minus 36, and A into C is 1 into minus 36, which is minus 36, and the factors of 36, that should give me the LCM, sorry, as minus 36, and sum as minus 5 is minus 9 and 4. So minus 9 into 4 is minus 36, and minus 9 plus 4 is minus 9 plus 4 is minus 5. So these are the factors, and I'm going to replace it here. So instead of 5x, I can write minus 9x plus 4x minus 36 is equal to 0. So x is common for the first two terms. For the next two terms, 4 is common, which gives me x minus 9 into x plus 4 is equal to 0. So that means either x minus 9 is 0 or x plus 4 is 0, and x cannot be negative, so our value for x is 9. So digit at tens place is equal to 9, and digit at ones place is 9 minus 5 is equal to 4. It's 5 less. Okay, we have to find the number, therefore required number is 94. Digit at tens place is 9, digit at ones place is 4, so the required number is 94. Okay, moving on to section D. Okay, for next question, that is question number 32, and we are going to solve part A of this using graphical method. We have to solve the following system of equations, and the system of equations are 3x plus y plus 4 is equal to 0. So let's get the coordinates for this. This is x, y. Yeah. Let's get a box for this. At least 2 points, 2 coordinates we are going to get. So when I put x is equal to 0 here, so this is 0 plus y plus 4 is equal to 0, which gives me y is equal to minus 4. So when x is equal to 0, y is minus 4, and let me put x is equal to, let's say, 2. So when I put x is equal to 2, this is 6 plus y plus 4, which gives us y is equal to minus 10. So y is equal to minus 10, and these are the coordinates of for the line 3x plus 4 is equal to 0. Now the next is 3x minus y plus 2 is equal to 0, and when I put x is equal to 0, so this is 0, which gives me minus y is equal to minus 2 and y is equal to 2. And when I put, let's say, x is equal to 1, so when I put x is equal to 1, this is 3 minus y plus 2, which gives me minus y is equal to minus 5, and y is equal to 5. So for this, I have the coordinates x, y. When x is 0, y is 2. When x is 1, y is 5. Okay, now let's plot the graph for this. So let's say this is y-axis, and this is the x-axis. Okay. X and y axis. Origin is, oh, so this is 1, 2, 3, 4, 5, and 6. And my negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and negative 7. This is 1, 2, 3, 4, 5, 6, 7, and 8. This is negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Okay, for the first one, it's 0, comma minus 4. So 0, comma minus 4 is here. This is the coordinates of the point 0, minus 4, where x is 0. The next is 2, comma minus 10. So 2 and minus 10 should be, this is negative 8. This is negative 9 and negative 10. So 2 comma negative 10 is here. So this is 2 comma negative 10. And for, let's join these points. So it goes through 2 comma minus 10. And if I produce it, it goes through, okay. So this is the graph for the first equation, which is 3x plus y plus 4 is equal to 0. So this is 3x plus y plus 4 is equal to 0. Okay, for the next one, it's 0, comma 2. So this is 0, comma 2. And the next one is 1, comma 5. So this is 1 and 5. Okay, if we plot the graph, it should, okay, so this graph should be something like this. And because my coordinates are not the exact. So if I take it, this point, this will point of intersection of these two lines, and because my coordinates are, the divisions are not equally spaced, so I'm going to take it as minus 1 comma minus 1. So these two lines are intersecting at minus 1 comma minus 1. So the solution of this system of linear equations is minus 1 comma minus 1, where x is equal to negative 1 and y is equal to negative 1. This is the solution using the graphical method, and these lines will precisely intersect at minus 1 comma minus 1 coordinate if these divisions are equal. So I have just drawn the rough sketch of this. So solution should be minus 1 comma minus 1. Let's move on to the next one, that is part B. Okay, for next question, that is part B of 32nd question. It's given that Tara scored 40 marks in a test, getting 3 marks for each right answer and losing 1 mark for each wrong answer, and had 4 marks been awarded for each correct answer and 2 marks been deducted for each wrong answer. So there are two scenarios. Tara would have scored 50 marks. So this is part B, and let's say the correct answers be X in number and incorrect attempts or incorrect answers by. So according to question, if they are, let's take this first scenario where there are 3 marks for each right answer. So if the number of correct answer are x, then the marks awarded for the correct answers are 3x, and there is negative marking for the wrong answer, and if the wrong answers are y's for 1 mark, so that means we have to detect. So if incorrect answers are y and marks for each incorrect answer is 1, so that means y are the incorrect marks or the marks for the incorrect answer, which has to be detected. So 3x minus y is equal to total marks scored is 40. So this is the first set of equations. Similarly, if 4 marks have been awarded to each correct answer, if 4 marks are awarded to each correct answer, then the marks for the correct answer will be 4x, and 2 marks be deducted for each wrong answer. Then the marks for wrong answer deducted being 4x minus 2y, the total marks is 50. Okay, going to solve these two sets of equations. So I'm going to use the elimination method, and I'm going to multiply the first equation with 4 and the second equation with 3. So if I multiply the first equation with 4, which gives me 12x minus 4y is equal to 160, and this is 12x minus 6y is equal to 150. Now let's subtract these equations by changing the signs of the terms of the second equation. This gets cancelled. Minus 4y plus 6y is 2y, and this is 10, which gives me y is equal to 5. So y is 5, and once again we have to find x. So this time I'm going to multiply this with 2 and this with 1. So this is 6x minus 2y is equal to 80. And let me just keep it as it is. 4x minus 2y is equal to 50. I'm going to subtract it once again, these two equations. So this gets cancelled this time, and this is 2x is equal to 30, which gives me x is equal to 50. So the correct answers are 15 and wrong answers are 5. So total questions in this question is wrong plus the correct ones, that is 20. So 20 is the total number of questions. And let's move on to the next one. Okay, for next question, that is 33rd, we have to prove that if a line is not parallel to one side of a triangle to intersect the other two sides in two distinct points, then prove that the other two sides are divided in the same ratio, which is the proof for the BPT theorem. So let's try to prove this, and for this let's draw a triangle, and a line is drawn parallel to the third side. So it has the vertices A, B, and C. And this is the line which is parallel to BC. So what is given to us is that DE is parallel to BC, and we have to prove that it divides the two sides in the same ratio, that is AD by DB should be equal to AE by AC. And for this we are going to do some construction here. And construction is that we are going to draw perpendiculars to AC and AB. So let this be perpendicular DM to AC and EN to AB. So these are the perpendiculars. Okay. And also let me join these two uh, points D and C and B to E. So I'm going to join B to E as well. Okay, so this is the construction I have drawn. So I have drawn DM perpendicular to AC and EN perpendicular to AB. And after that, I have joined E to B and C to D. Okay, now the proof. So in the proof, I'm going to take this triangle that is going to divide the area of the triangle ADE by area of triangle BDE. Now for area of triangle AD, let me take a base as AD. So this is the base, and this is the height I'm going to take. So base is AD and height is EN. Similarly, for triangle BDE, base is BD and height is outside in the triangle because this is an obtuse angle triangle, so height is out. So I'm going to write half into base BD into EN. We can strike these off and it's AD by BD. Let this be first set of equation. Now, once again, I'm going to divide the area of triangle ADE by this time area of triangle DEC. And for area of triangle AD, this time I'm going to take base as AE. So this is the base AE and height is DM. Triangle DEC is an obtuse angle triangle that has base EC. If I take base as EC, its height is outside, which is DM. So this gets cancelled and this is equal to AE by EC. If we compare these two set of equations, we see that we have already almost got the result, that is AD upon DB is equal to A upon AC. So these two sides will be equal once these two sides are equal, but these are not equal. And the only thing left here is the area of triangle BD and area of triangle DD. If we are able to prove that these two areas are equal, then these two sides will, the LHS of these two equations will be equal, which will eventually prove that these two RHS sides are also equal. Now, the area of triangle BDE is equal to area of triangle DEC because they are on the same base DE and they are between the same parallels. And we know that uh, area of triangles between same parallels and on same base are equal. So that means area of triangle BDE is equal to area of triangle DBC. Let this be third set of equation. So instead of replacing the value DEC and BC, I'm just going to write from 1, 2, and 3. If we compare these equations 1, 2, and 3, we get that AD by DB is equal to AE by EC, which is the BPT theorem. So hence we have proved that if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, then the other two sides are divided in the same ratio. Let's move on to part B of the same question. Okay, for part B of question number 33, is given that AB, AC, and median AD of triangle ABC are respectively proportional to PQ, PR, and median PM of another triangle PQR. So we have to show the triangle ABC and triangle PQR are similar. So let's say this is the triangle ABC. So this is triangle ABC. And this is triangle, let's say this be the triangle PQR. Okay. Now side AB and AC and median AD. This is the median AD. And let's say this is the median PM. So I'm going to name it, this is the median AD and this is the median PM. And what is given to us, let me just write it down. So AB proportional has side PQ code, AB is proportional to PQ, and AB is proportional to PQ, AC is proportional to PR, AC proportional with PR, and AD. This is in proportion with PM. Now we have to prove that triangle ABC is similar to triangle PQR. So what we have to prove is that these two triangles, triangle ABC is similar to triangle PQR. That's what we have to prove. And let's jump on to proof. So what is given to us, let me just write it down. And okay, so this is AB by PQ is equal to AC by PR is equal to AD by PM. That is what is given to us. And in this case, we are going to do some construction here for these two triangles. And the construction is that we are going to extend AD to L such that AD is equal to L, and I'm going to join C to L and B to L. Similarly, I'm going to extend PM to N. So I'm going to extend PM to N such that PM is equal to Mn, and let me join Qn and Qr. So the construction that I have done here is I have extended AD to L, and I have extended PM. So this is PM to N, this is AD, such that AD is equal to DL, and here such that PM is equal to Mn. And what I have done apart from this is that I have joined B to L, C to L, Q to N, and R to N. So this is what I have done now. So it was given that AB upon PQ is equal to AC on PR is equal to AD upon PM. And what I'm going to do, so this is what was given to us. And I'm going to write AB upon PQ is equal to, let me write this. This is 2 times AC and this is 2 times PR. If the sides in proportion, then their double is also in proportion. This is, okay, this is not. I'm going to double. This is AC by PR, and I'm going to double these. 2 times AD, 2 times PM. So 2 times AD. So 2 times AD will give me AL. So this 2 times AD is AL because AD and DL are equal, and 2 times PM is PN. So this is PN. So what I have got here is AB by PQ is equal to AC by PR is equal to AL by PM. Okay. So in this triangle, that is AB, AL, this AB upon AL is equal to PQ upon PN is equal to AC upon PR. Now, uh, in this triangle, in quadrilateral ABCL, so if I look closely at this quadrilateral in quadrilateral ABCL, AD is equal to DB, and this is by construction also. BD is equal to DC because so BD is equal to DC. Reason being that AD is a median and D is the midpoint. So D is midpoint. So these are actually the diagonals that are bisecting each other. So if diagonals bisect each other, so in this quadrilateral diagonals bisect each other, so that means quadrilateral ABCL is a parallelogram. And if it's a parallelogram, so that means AC is equal to BL because opposite sides of a parallelogram, they are equal. Now, similarly, just like we have proved that quadrilateral ABCL is a parallelogram, similarly, we can prove that this quadrilateral, similarly, this quadrilateral, that is, the name of the quadrilateral is PQNR is a parallelogram. So PQNR is a parallelogram and which gives us PR. PR is equal to QN because these are the opposite sides. So AC is equal to BL and PR is equal to QN. So I'm going to replace the value here. So instead of AC, I'm going to write, so this is AB by PQ and AC is equal to BL and PR is equal to QN. So BL and QN, it's BL and QN is equal to AL by PL. Now AB, these sides are in proportion and these sides are for quadrilateral ABL. So and AB is in proportion with PQ, AL is in proportion with, so this AB is in proportion with PQ, AL comes in proportion with PR, and BL comes in proportion with QN. So that means these two triangles are similar. So I can write that. So by SSS, similarity rule, this triangle, the name of the triangle is ABL. So this is ABL is similar to triangle, this is PQN. So if these two triangles are similar, so that means this angle, let's say this is angle 1 and 2. So angle 1 and 2 are equal because these are the corresponding angles of the similar triangles. The corresponding angles of the similar triangles are equal once the triangles are similar. Similarly, just like we have proved the triangle ABL is similar to triangle PQN, similarly we can prove that this triangle, that is triangle ACL, is similar to triangle PRN. Triangle ACL is similar to triangle PRN. And once these two triangles are similar, so that means their corresponding angles are equal. That is, angle 3 is equal to angle 4. So which would give us angle 3 is equal to angle 4, reason being CBST. So let's say this is the first set of equation, this is the second set of equation. And if we add them, so let's try to add them. So this is 1 plus 2 gives angle 1 plus 3 is equal to angle 2 plus 4. And if angle 1 plus 3 is angle A and angle 2 plus 4 is angle B. So angle A is equal to angle P and angle A is equal to angle P and AB upon PQ also AB upon PQ is equal to, this is PQ upon PR, which is given to us. So angle A is equal to angle P and AB is in proportion with PQ and AC is in proportion. So AB is in proportion with PQ and sorry, this is AC is in proportion with PR. So this is AC. So this AC is in proportion with PR. So this gives us that by SAS similarity rule, these two triangles are similar. So by SAS similarity rule, we can say that triangle ABC is similar to triangle PQR, and hence we have proved what was asked in the question. Let's move on to next question, and the next question is question number 34. Okay, for next question is given that from the top of a 45-meter lighthouse, the angles of depression of two ships on the opposite side of it are observed to be 30 and 60 degrees. So this is question number 34. And this is, let's say, 45-meter lighthouse. So 45-meter lighthouse, the angles of depression of two ships are on the opposite side. So let's say these are the two ships. Okay. And from here, the angle of depression, let's make the angle of depression here. So angle of depression, for the angle of depression from this point, from the top of a 45-meter lighthouse, the angle of depression for the first ship is observed to be 30 degree. So if this is 30 degree, this is horizontal, this is horizontal, these are parallel, this is the transversal. So this angle is also equal to 30 degree alternate angles. And the another angle of depression is for 60 degree. So this is 60 degrees, so that means this angle is also 60 degree. Let AB be the height of the lighthouse. This is C and this is D. Now, if the line joining the ship passes through the foot of the lighthouse, we have to find the distance between the ship, that is the CD. And for that, we have to find CB and BD separately, and we have to use the value of root 3, which is 1.73. Now, these are both the right angle triangles. So the first in right angle triangle, or let me just uh, uh, make the assumption here. So let AB is equal to 45 meter be the height of lighthouse. Now, in right angle triangle ABC, we can use tan 30. So tan 30 is equal to AB by BC, and tan 30 is 1 by root 3. So AB by BC, and if we cross multiply this, that gives me AB is equal to BC by root 3, and BC is 45 by root 3. And if we rationalize this, this gives me root 3 by root 3. So this is 45 root 3 by 3. This is 15 root 3. So we have got AB, which is uh, 15 root 3. Now, this we have to calculate BC. Sorry. So tan 30 is 1 by root 3, which is AB by BC. And if I cross multiply this, let me just get BC, which is AB root 3, and AB is 45. So BC is 45 root 3 meter. Now another right angle triangle is ABD. So I'm going to use tan in that triangle. So in right angle triangle ABD, tan 60 is equal to AB by BD. AB is 45 and BD is not known. Tan 60 is root 3 is equal to 45 BD, and BD is equal to 45 by root 3. Let's rationalize this by multiplying and dividing by root 3. So 45 root 3 by 3 is 15 root 3. So this is 15 root 3. And now we have to find the distance between the ships, which is CD. So CD is equal to CB plus BD. So this is CB plus BD. And CB is 45 root 3. So this is 45 3 plus 15 root 3. And 45 plus 15 is 60 root 3. This is 60, and the value of root 3 is clearly the question, which has to be 1.73. So this is 1.73, and if you multiply this, so 3 is equal to 6 3 is 80, and 7 6 is 42, plus 1 is 43, and 6 1 is 6 plus 1 is 10. So 10380 with, so this is the distance between the ships, which is 103.8 meter. So 103.8 meter is the distance between the ships. Let's move on to next question. Okay, for next question is given that the perimeter of a certain sector of a circle of radius 5.6 meter is 20 meter. We have to find the area of the sector. So this is question number 35. And let's say this is the circle with center O and radius OA and OB. So this is OA, OB. Now the radius is 5.6 meter. This is 5.6 meter and its perimeter is 20 meters. So let's write down what is given to us. Now the perimeter is 20 meter and this is the perimeter of sector. And the perimeter means the length of the boundary. Now the sector has a boundary of OA plus OB and length of minor r AB which is equal to 20. Now OB is 5.6, 5.6. Let this central angle be theta, and we know the length of the arc is given by theta upon 360 into 2 pi into r. So 5.6 plus 5.6 is 11.2. So this is theta by 360 into 2 into 22 by 7 into 5.6 is equal to 20 minus 11.2, which gives me 8.8. So this is 180, this is 11, and 90, this is zero point 0.8, and theta is equal to 8.8 into 90 upon 11 into zero point 0.8. So if I take these decimals off, so this is 11 and theta is 90 degree. So that means this is a quarter. Now we have to find its area. So area of the corresponding sector with the angle 90 is theta by 360 into pi r square. So theta is 90 by 360 into 22 by 7 into 5.6 into 5.6. So this is 4 to 11. This is zero point 0.8 and this is zero point 0.4. And if we calculate this, this is 11 into zero point 0.4 into zero point 0.6 and it's in meter square. So this is the area meter square. And if I multiply this, which is 11 into zero point 0.4 into 5.6, which gives me 24.64. So this is 24.64 meter square is the area of the sector. Let's move on to section E. Okay, we are on section E, and these section consists of three case-based questions of 4 marks each, and we are going to solve the first one, that is the question number 36. And it says that a ball is thrown in air so that after t seconds, its curve is given in the picture, and this t horizontal axis is the time axis, and the vertical axis is the height. And the equation of this graph is h is equal to 25t minus 5t square, which is a sort of quadratic equation. We have to observe the graph of the polynomial and answer the following questions. The first one is to write the zeros of the given polynomial. So this graph intersects the x-axis at 2 points, that is x is equal to 0. This is x is equal to 0, and here it's x is equal to 5. So the zeros of the polynomial are x is equal to 0 and x is equal to 5. These are the zeros of the polynomial. For the second part, we have to find the maximum height achieved by the ball. So maximum height achieved by the ball is here, which is when the time is 5 by 2 seconds. So let's find the height. So height is given by this equation, and so we have to find the maximum height, and this height is maximum when time is equal to 5 by 2. So height maximum is equal to, we are going to replace the value of t by 5 by 2. So 25 into 5 by 2 minus 5 into t square would be 25 by 4. So this is now equal to 125 by 2 minus 125 by 4, which gives me the LCM as 4. And this is 125 into 2 is 300 minus 125. So 300 minus 125 should be 125 by 4. And this is 4 threes are 12, 4 ones are 4, and twos are 8 and 5. So 31.25 meter is the maximum height at time is equal to 5 by 2 seconds. Okay. Now for the third part, we have to find after throwing upward how much time did the ball take to reach to height of 30 meter. So let's once again use the equation for that is the quadratic equation or the equation of the polynomial 25t minus 5t square. Here height is given, so height is 30 meters, so this is equal to 25t minus 5t square, and shifting all these to the left hand side gives me 5t square minus 25t plus 30 is equal to 0. Okay, so 5 is common, so t square minus 5t plus 6 is equal to 0. And let's try to solve it using the factorization method. So the factors of 6 are 2 and 3. So this is minus 2t minus 3t plus 6 is equal to 0. T is common for the first two terms, and minus 3 is common for the next two terms. And t minus 2, this is t minus 2, and t minus 3 is equal to 0. So it gives me the value of t here is t is equal to 3, either t is equal to 2 or t is equal to 3. Now, so we have to check. So we have two values of time. We have to check for which value of t it gives me the height uh, 30 meters. So if I replace here, if I put the value of t as 2, so this is 50 minus 2 square is 4, 5 fours are is 20, which gives me 30. So when t is equal to 2, height is 30. So that means t value of t is 2 and it cannot be 3. Okay. For okay, now we have to find the two different values of t when the height of the ball is 20 meter. So height of the ball is 20 meter can be, let's say this is, so there are two values of t because for the same height, one is going upward and the other another one would be coming downwards. Okay, so let's use the equation and put it height as 20. So this is part B of part B of part 3. So this is now height has to be 20 is equal to 25t minus 5t square. And this becomes the quadratic equation 5t square minus 25t plus 20 is equal to 0. And 5 is common, so t square minus 5t plus 4 is equal to 0. This is the quadratic equation 5t plus 4 is equal to 0. And we are going to use the factors of 4, that is minus 4t minus t plus 4 is equal to 0, which gives me t as common for the first two terms. And for the next two terms, the common is, okay, so this is minus 1 is common, this is t minus 4. Now t minus 4 is common. So I have two factors t minus 4 and t minus 1, which gives me either t minus 4 is equal to 0 or t minus 1 is equal to, so that gives me two values of t. So that means when going upward after 4 seconds, its height may be 20, and when coming down after 1 second, its height may be 20 meter. So for these two times, its height is 20 meter. Okay, coming on to question number 37. For next question, that is question number 37. It's given that the word circus has the same root as circle. So both are these the same words going in circles, and the circus is performed in a closed circular area with various entertainment acts, including human skill and animal training. Now, the circus tent is cylindrical up to a height of 8 meter and conical above it. Diameter of the base and height of the tent is given. We have to find the slant height of the conical part. So let's draw the rough sketch for this. Let's say this is the cylindrical part, which has height 8 meter, and above it's the conical part, and the base of the cone and the cylinder are circular. Height of the cylindrical part is 8 meter, and total height of the tent is 18.5 meters. So this is the total height of the tent, which is 18.5 meter. And from the total height, if I subtract the cylindrical height, that gives me the height of the conical part. So height of cone is equal to 18.5 total height minus height of the cylindrical part, which is 10.5 meter. So this is 10.5 meter, and diameter is 14, so 28. So diameter is 28, and the radius of the cylindrical as well as the conical part is common, which is 14. And we have to find the slant height of the conical part. So slant height of the conical part is given by root of h square plus r square, and height is 10.5 square, radius is 14 square. Okay, so 10.5 square. Square of 10.5 is 110.25. So this is 110.25. 110.25 square of 14 is 96. This is 14 square, 14 and square. So 110 plus 196, 110.25 plus 196 is plus 96. It gives me 110, gives me 306.95. So this is 306.25, and square root of 306.25. We can find it using long division method, and this is 17.5 meters. So 17.5 meter is the slant height of the cone. Now we have to determine the floor area. So floor area is, this is the floor area, which is in, which is circular. So this is pi r square, and pi is 22 by 7, radius is 14 into 14. So this is 14 into 44. So 14 into 44, the value of the floor area is 616 meter square. Now coming on to the area of cloth used is the third part, and the area of the cloth used would be the surface area of, this is the surface area of the cylindrical part plus the curved surface area of the conical part, that is 2 pi rh plus pi rl. So this is third part A, and area of cloth used is equal to pi rl plus 2 pi rh. So common here is pi r, which leaves with L plus 2h common. So pi is 22 by 7, radius is 14, slant height is 17.5, and 2 into h, height of the cylinder is 18. So this is, so this is 244, and 17.5 plus 16. So 44 into 17.5 plus 16 is 0.576 is 13. This is 33.5. Okay, now 44 into 33.5. So this is 44 into 33.5 gives me 1474 meters square. So this is 1474 meters square is the area of the cloth used for making the tent with the conical and the cylindrical part. And for part B, we have to find the total volume of air inside an empty tent. So that is the volume of tent, which is the volume of cylindrical part, which is pi r square, and the volume of the conical part, which is pi 1 by 3 pi r square h. So this is the height of the cylinder, this is the height of the cone. And the common in this case is pi r square, so which leaves me h1 plus 1 by 3 h2. And let's replace the value. This is 22 by 7, 14 into 14, and height of the cylinder is 8 plus 1 by 3 into height of the cone is 10.5. So this is now 3.5, and this is for 244 into 14, and 8 plus 3.5 is 11.5. So if I multiply all these 44, this is 44 into 14 into 11.5 gives me 7084 meter cube. So this is 7084 meter cube should be the volume of air inside the tank. Thank you for watching. For the final one, that is question number 38, the survey was done on 120 people for holidays, and it was collected that how they used which transport or the type of transport they used on the last holiday. The following pie chart was prepared. And over the pie chart, we have to answer the following questions. For the first one, if one person is selected at random, find the probability that he or she is traveled by bus or ship. So ship or bus, we have to find the probability. So instead of finding the number of people traveling by the ship or the bus, we can use the angle. And because the total, this complete angle will be 360. So uh, probability that a person, that is he or she, they traveled by bus or ship. If you are using the angle, then the complete angle should be known. And if you are using the number of persons, then the complete, that is the total people you should know. But because we are using the angles, so the for the bus and ship, the total angle is 33 plus 36, and it has to be divided by the complete angle 360. So if we are using the angle, we are using the complete angle. So this is 69 by 360, which gives me 23 by 120. So 23 by 120 is the probability of the people traveling by bus or ship. Okay, and for the next question, which is the most favorite most mode of transport and how many people used it? So, because this is the pie chart, and from this chart we can easily draw the conclusion that the greatest angle is 177 degree, which is for car. So, most favorite mode of transport is car. So, this is the most favorite mode of transport, which is car, and we have to find the number of people using it. So, number of people using it would be the angle divided by the complete angle into people. So this is 3, 12, 75, 77, this is, sorry, 177. And this is 177. So this is 3 5s are 15, 3 9s are 27, and this is 59 people. So 59 people use car. And for the third one, we have to select a person is selected at random, and if the probability of that he did not use the train, so probability of not using the train is given. So probability of not using train is equal to 4 by 5, and we have to find the probability of using the train, probability of number of people who use train. So this is equal to 1 minus probability of not using train. The people who are not using train, so this is 1 minus 4 by 5, which is equal to 1 by 5. So 1 by 5 is the probability of the number of people using the train. And also we have to find out the number of people who use train. So number of people who used train should be the probability multiplied by the total people. So number of people who use train is equal to 1 by 5 into 120. So 5 twos are is 10 and this is 24. So 24 people are using the train. And the number of people who used aeroplane is, we have to find out its probability is given. So this is third part B. So probability of people using train, probability of using, sorry, aeroplane is given, which is 7 by 60. And we have to find the number of people using aeroplanes. So number of people using aeroplane is probability multiplied by the total people, which is 120. So 2, and this is 14. So 14 people are using airplane as the mode of transport. We have to find the revenue generated by this airplane or the air company, and the fare is rupees 5,000 per person. So 5,000 per person, we have to calculate the revenue generated. So it has to be multiplied with the number of people using airplane, which is 14, and has to be multiplied with 5,000. So 14 into 5 is 70. So this is 70,000 rupees is the revenue generated by the air company for the people who are using the aeroplane. And this finishes our this set of question paper. Thank you for watching.